Hello everyone, welcome to my class. In today's class I am going to cover solving exponential equations and logarithmic equations. So let me start the class right away. So let me recall the conversion chart, that means the equivalent expressions for log and exponential functions. So here the first column is for exponential forms, second column for log forms, and logarithmic function is y equals to log x to the base b, which is same as saying x equals to b raised to the power y. Here's the example. And on my right side, the properties of exponential functions. We discussed this one in earlier sections. Uniqueness property, the uniqueness property of exponential equations. If you have a same base exponential functions equal, then we can equate the exponent. And now let's talk about the properties of logarithmic functions. Let me scroll down here. That's better. Properties of logarithmic functions. Log of the product equals to sum of the logs. Log of the quotient equals to difference of the log. Log to the power p, we can extract the power as a coefficient. Log of b with same base b is 1. Log 1 with any base b is 0. And b to the power log x with base b is x. Alert: log of the sum or difference is not equals to sum of their logs or difference of their log. And note, ln e is 1. Awesome. Similarly, the change base formula, log m with given base b, we can rewrite with our desired base. Let's say our desired base is a, then log m with base b turns out to be log m with desired base a over log b with desired base a. If we pick a equals to 10, then this becomes simply log m over log b, or if we pick a equals to e, then this turns out to be ln m over ln b. I hope this change of base formula makes sense to you all. Now next, the uniqueness property of logarithmic equations. If you have the same base log functions equal, then we can equate the argument. Now with those properties, now let's solve some questions. So first example 1, solve the exponential equations a through c. So part A, the given exponential equation is 3 raised to the power 2x equals to 27. So on my left side, this is exponential functions. Let's rewrite 27 in terms of exponential. That is, we can rewrite 27 equals to 3 raised to the power 3. Then we can use the uniqueness property of exponential functions. We have the same base exponential functions. Here the base is 3. Then we can equate the exponent. So then the next step, 2x equals to 3, hence x equals to 3/2. I hope this makes sense to you all. So in part B, the exponential equation is 10 to the power x minus 5 equals to 78. So now I cannot rewrite 78 equals to 10 to the power some exponent. So that means I need to solve this exponential equations, but I cannot use a uniqueness property at this step. Then the idea is to get rid of these exponentials. Let's multiply by logarithmic functions both sides, because we know logarithm functions and exponential function are inverse to each other. So let's take log both sides. Then the left side is log of 10 to the power x minus 5 equals to log of 78. And then by the property, the left side is simply x minus 5, because log 10 with same base 10. the log has base 10 here, which turns out to be 1. And on the right side is as it is, log of 78. Then x equals to, let's add 5 both sides. So x equals to 5 plus log 78 with base 10. Then using calculator, x turns out to be approximately 6.89. Great. Part C, solve these exponential equations with different bases. Then the idea is we need to take log both sides. Here I multiply both sides by natural log. So the first step here, so take ln both sides. So ln of 5 raised to the power 2x plus 1 equals to ln of 9 raised to the power x plus 1. Then using properties of log, I can bring this exponent as a coefficient. So 2x plus 1 times ln 5 equals to x plus 1 times ln 9. I hope this makes sense to you all here. Then in the next step, let's FOIL, multiply ln 5 inside, multiply ln 9 inside, which turns out to be this expressions here. Let me scroll down. Yep, here. And in the next step, let's rewrite x terms one side and terms without x another side. So here, 2x ln 5 one side, bring x ln 9 to the left side, and to the right side ln 9 as it is, and take ln 5 to the right side. I hope this step makes sense to you all. And in the next step, let's factor the x out, because our goal is to solve for x. So we factor the x from the left hand side, and then what left? 2 ln 5 minus ln 9 left. Right side as it is. Then to find the value of x, divide both sides by this coefficient of x. So then x equals to ln 9 minus ln 5 over 2 times ln 5 minus ln 9. And using calculator, this turns out to be approximately 0.58. Great. So even if we don't have equal bases on this exponential equations, we found the value. The idea is taking log both sides. Great. Let's move on. Example 2, solve the logarithmic equations A through C. Part A, solve log of 9x plus 1 with base 8 equals to 2. So then use the definitions. So its equivalent forms in exponential is 9x plus 1 equals to 8 raised to the power 2. The next step, 8 raised to the power 2 means 64. Subtract 1 is 63. 9x as it is on our left hand side. And to find the value of x, divide both sides by 9, and it turns out that x equals to 7. I hope this makes sense to you all. So now let's move on. Part B, 3 times natural log of x plus 4 minus 5 equals to 3. So first, let's simplify the constant here. So 3 ln x plus 4 as it is, then bring this 5 to the right hand side. So 5 plus 3 is 8. Next, divide by 3 both sides. So ln x plus 4 equals to 8 over 3. And next, let's write this equivalent form. Let's write the equivalent form of these log functions in terms of exponential here. So then x plus 4 equals to, here the base of the ln is e, so then e raised to the power 8/3. I hope this makes sense to you all. And then now solve for x, so subtract 4 from both sides. So x equals to then e to the power 8/3 minus 4. Using calculator, it turns out that x equals to approximately 10.39. I hope it makes sense to you all. So now, here in part A we solve logarithmic equations. In part B we solve exponential. Now in C, let's solve logarithmic equations again. So here, part C, log of x plus 4 with base 8 equals to 1 minus log of x plus 6 with base 8. So the first step, let's try to collect the log terms together. That means bring this log x plus 6 with base 8 to the left side, so which I did here. Then I can use the properties of log. We know log of the product is the sum of their logs. So then this sum equals to log, only one log common, and then multiply the argument x plus 4 times x plus 6. And then I wrote 1 equals to, here's our log function has base 8, so log 8 with base 8, because this is 1. Let me show you the property here, what I used here. I used, do I have the properties here? Oh, maybe, oh, here. Log b with base b turned out to be 1, and log of the product gives me sum of the logs. I use these two property. Let me scroll down. Here. And then the next, since we have the same log function with the same base on both sides, then we have only the argument equal. That's the uniqueness property. Then x plus 4 times x plus 6 equals to simply this 8. I hope this makes sense to you all. And then now next, let's FOIL x plus 4 times x plus 6 turns out to be x squared plus 10x plus 24. Right side 8 as it is. Now bring this 8 to the left side. Now we have the quadratic equations, which is x squared plus 10x plus 16 equals to 0. We can factor this quadratic equations. The two forms are, we have the two linear factors, x plus 8 and x plus 6. Right side is 0. And we know the product of two numbers equals to 0 means either number should be 0. That means either x plus 8 equals to 0 gives me x equals to minus 8, or x plus 2 equals to 0 gives me x equals to minus 2. Now we have these two possible answer, but let's check. Now let's check those values on the given log equations. So here, when x is minus 2, there is no problems. Both of these arguments are positive. But when x is negative 8, then this turns out to be negative 8 plus 4 is negative 4. But we cannot define the log function for negative argument, because the domain of log function is strictly bigger than 0. So then we have to disregard this solution, which is an external solution. Hence, x equals to negative 2 is the only solution of these logarithmic equations. I hope this makes sense to you all. Now let's move on. Now example 3. Simplify the equations. Example 3. Simplify the equations A and B. So in part A, it says expand these logarithmic functions. So using property, let's expand this one. And this is written in the compact form. Let's expand. So here, let's start. So we know log of the quotient is the difference of the logs. So that's what I did here. ln of this numerator minus ln of this denominator. And we know log of the product equals to sum of their logs. So here then ln 5x plus ln of radical 3 minus 4x. I hope this makes sense to you all. And this minus as it is. Similarly here, ln of 2e plus ln of x minus 1 power 3. I use a bunch of properties here. Similarly, now here's I copy the ln 5x as it is, and the second one here's the radical is same as power 1/2, which I did here. And here I distributed the negative sign, so ln 2e minus ln of x minus 1 power 3. And then I can, again here's ln of the product goes to the sum of the logs, ln's. So here is ln 5 plus ln x. I hope it makes sense to you all here. Then in the next step, I can take this power as a coefficient, so 1/2 times ln 3 minus 4x. Keep in mind, I cannot distribute ln inside, okay? And ln of 2 minus ln of e, which is 1, and bring this 3 as a coefficient, so 3 times ln x minus 1. This is the simplest forms of this given log functions. I hope this makes sense to you all. Now part B, solve this equation here. 60 equals to 66 over 1 plus 10 times e to the power negative 0.05x. So begin the solutions. So if there is nothing here under 60, that is there is a 1, then I can rewrite 60 equals to 60 over 1, and I copy the right hand side as it is. And now here is I cross multiply here. I cross multiply 60 times this denominator equals to 66 times this denominator 1, which I did here. So 60 times this denominator plus 60 times this denominator equals to 1 times 66. In the next step, I divide both sides by 60, so then 1 plus 10 times e to the power negative 0.05x equals to 66 over 60, which is 1.1. In the next, subtract 1, because our goal is to find the value of x, so let's try to isolate these terms. So then 10 times e to the power negative 0.05x equals to 1.1 minus 1. I hope this algebra makes sense to you all so far. Then 1.1 minus 1 is simply 0.1. Next, divide by 10. Then we have e to the power negative 0.05x equals to 0.01. And now we know how to solve the exponential equations here. Now it's reduced to the exponential equations. So we take ln both sides. So ln of e to the power negative 0.05x equals to ln of 0.01. And the left side, ln is 1, so simply negative 0.05x equals to ln of 0.01. Then we divide both sides by negative 0.05. Using calculator, it turns out to be approximately 92. I hope this algebra makes sense to you all. Please do yourself and try to understand the algebra here. Now one final remark. One very practical applications of the natural log involves atmospheric pressure. So let's do one example. So the formula of atmospheric pressure is H, that's the height, equals to 30 T, T is the temperature, plus 8,000 times ln P0 over P. Here P0 is the pressure at sea level and P is the pressure at altitude H. And the P0 is 76 cmHg. The cmHg is the centimeters of mercury. This is the unit. Awesome. Now let's do example 4. A sophisticated spy plane is cruising at an altitude of 18,250 meters. If the temperature at this altitude is negative 75 degree, what is the barometric pressure? That is what is the atmospheric pressure. We have the formula. Here is the formula. Great. So now let's begin the solutions. Here is our formula. So let's use the values here. H is 18,250, T is negative 75, P0 is 76. In the next step, multiply these two numbers and add and subtract here, which turns out to be this line here. Let me scroll down this line. And then now divide both sides by 5,750. So now we have these logarithmic equations. Then let's rewrite these logarithmic equations in exponential form. So that means 76 over p equals to, here the base is e, so e to the power 73 over 23. Then p equals to 76 over e to the power 73 over 23 using calculator, which turns out to be approximately, the pressure is 3.2 cm/Hg in centimeters of this mercury. Great. So I hope this makes sense to you all. So we finish these sections as well as we finish this chapter 4. Thank you.